Physics hits a mathematical wall at the quantum-gravitational boundary. Pushed to extreme topological scales, continuum mechanics break down, producing infinite singularities that stop calculation entirely. Standard physical frameworks struggle to resolve these boundaries. They rely on frictionless analogies and arbitrary axioms to patch over mathematical black holes, failing to resolve the absolute nature of the singularity itself. The theory of infinity, or TOI, approaches this boundary through a different mechanism, the psi-phi theta twist theory. This is a generative triad consisting of the invariant fold, the organizing symmetry, and the origin evolution. This triad dictates a rigorous process of creation ex totalitate. It maps exactly how formed intelligible structure is extracted directly from a pre-ontological indeterminate totality. By replacing arbitrary axioms with this strict ontological extraction, the framework yields the golden set, a maximally stable, bounded, and internally coherent cosmos. To verify the resilience of this architecture, we apply mathematical stress testing. We inject extreme integer pressure into the system to map the exact fault lines where continuous mathematical topology collides with discrete boundaries. This boundary testing requires strict auditing. As the geometry distorts, the system must precisely separate genuine thermodynamic friction, actual resistance in the math, from mere mathematical pareidolia, or algorithmic artifacts. To test the absolute limits of the golden set's continuous trigonometric geometry, we execute the third harmonic stress test. The condition for this test involves deliberate extreme dimensional distortion. The continuous wave's spatial phase is violently forced out of its standard dimensions. Mathematical proof demonstrates that under extreme discrete integer pressure, continuous manifolds resist shattering by locking their physical phase to an indestructible orthogonal grid and channeling the resulting structural friction into antispace. We start with a baseline continuous geometry. At this stage, the structure is safely governed by the second harmonic trigonometric gate, functioning as a predictable two-dimensional quadratic curve. Deliberately injecting the third harmonic violently warps the continuous wave, forcing it out of standard dimensions and expanding into a complex 3D topology. As the continuous wave bends into a complex cubic shape, Fibonacci masses stretch across 3 dimensions. Reaching a breaking point, the manifold refuses standard Euclidean space. Sheer internal pressure forces the ejection of mathematical phase roots, the scattered purple points, entirely out of the physical plane. When topological mass becomes too extreme, the system prevents the continuous structure from shattering by forcing excess phase roots into a latent complex domain. We can analyze the specific algorithmic output generated by this complex cubic topology when it is evaluated by a computational engine. The solver natively outputs a highly specific complex phase root, but formats the result in a way that factors out and obscures the true spatial coordinate. To isolate the geometric truth, we strip away that algorithmic formatting. By mathematically distributing the quantum dyad, the square root of 2, back into the complex parenthesis, we isolate the raw spatial coordinate. The real physical phase of this complex root resolves to an exact coordinate, pi over 2. Even when violently twisted into the third dimension, the golden manifold refuses to abandon its foundational geometry, forcing the real phase to remain permanently locked to this orthogonal grid. The pi over 2's signature functions as the permanent, indestructible architectural steel of the Fibonacci wave. Because the real channel seals itself perfectly at pi over 2, the entirety of the geometrical distortion, the sheer cost of moving the data, is banished exclusively into the latent imaginary channel. Topological torsion is carried across complex branches without leaking a single drop of thermodynamic friction into the real Euclidean payload. Where does that massive thermodynamic shear cost go once it is banished into the imaginary channel? The continuous universe chooses an explicit mechanism for handling this excess mass, the hyperbolic wormhole. Adding imaginary pi over 2 inherently inverts spatial volume. The structure literally everts, turning inside out to form a smooth, saddle-shaped hyperbolic geometry. Euler's continuous geometry proves this formally, causing the boundary negative signs to flawlessly collide and cancel out. The spherical trigonometric wave inverts itself into a pure hyperbolic tensor. The imaginary amplitude we captured during our earlier decompilation is the exact physical one-dimensional spatial root of this hyperbolic antispace. By scaling this amplitude by the quantum dyad, the spatial geometry inside this anti-universe perfectly and identically balances. When pushed past its breaking point, a Fibonacci trigonometric wave opens a wormhole and safely deposits the excess mass into the hyperbolic anti-universe. These fundamental microscopic wormhole dynamics ultimately dictate the much larger macroarchitecture of our continuous exponential universes, securing the entire framework against extreme topological pressure. The absolute spatial boundaries of these continuous exponential spaces are entirely governed by a specific discrete integer, the number 6. This table demonstrates the hexatic conservation law. The apophatic gate isolates the square root of 6. The manifest positive date collapses to the Riemann zeta basal limit, yielding negative pi squared over 6. The manifest negative gate targets the natural log of 6 over 3. Regardless of the continuous phase permutations applied to the math, the physical roots systematically collapse into mathematical pockets uniquely governed by the integer 6. The pi over 2 phase lock and these hexatic limits are manifestations of the exact same mathematical architecture. The Conrad invariance postulate states that the discrete integer acts as an absolute ideal, hovering a microscopic log residual above the continuous limit rail to actively tune the physical phase space. The discrete integer integrates with the continuous transcendental plane without resistance or pollution. Discrete geometric boundaries serve as the absolute frictionless scaffolding that permanently bounds the physical phase space, rendering the architecture mathematically indestructible against extreme continuous stress.